All right, so yeah, like I said, my name's Colin Hoy. I work at AV&C in New York. We do like various types of installations, large and small, mostly large-scale architectural type installations. So yeah, feel free to take a gander at the site. Yeah, we're basically doing 2, 3, 4, 5 installations at a time, mainly due to the length of the installation period or the programming period. They usually take quite some time. So yeah, take a look. Hit us up if you got any work you guys need to get done. Anyway, so if you haven't already, go ahead and go to the link I provided in the email, and just go ahead and clone the repo. I also put the GitHub desktop in there for you guys. We're not going to really be using it. I'll probably use it a few times and just kind of show you super basic ropes how to use it, like a Git flow type thing. But yeah, we won't be having you guys like do any commits or anything, so it's mostly optional for you guys. Yeah. So does anybody not have the repo downloaded? Right on. You may want to, if you hadn't got it since last night, I would just reclone it. I did some updates last night, put some new stuff in, so you're up to date. Right on. So if you don't know who I am, I'm Choi on Discord, and like C Hoy on Discord, and Pro Choi on the forums. So if you guys ever have any questions or whatever, feel free to hit me up. I recognized a few of you guys' names in the email, so pumped to finally meet some of you guys. Right on. So I guess we'll get into it. So when you're working with large-scale installations, first thing you're going to realize is that you're going to need some sort of process to repeat what you've done before, as well as work with other people. So obviously the most logical thing would be to use some sort of versioning system. So yeah, so we use GitHub, obviously. So one thing that's slightly new to GitHub that kind of moved over to is these templates in GitHub. So what you can do is you can actually template a repository now, which you couldn't do before. And so basically you can just, I'm not going to do it with this thing, but you can template this, and that becomes a template for your projects going forward. So as you are, developing whatever you are, a VJ system or, an installation system, and you're working towards making it something that's reusable, you can template it up. And that's what we do. We basically, like, we have a new project. I'll go to our main GitHub and just clone off the template, and then all of our base components and et cetera, are going to be there, and we can just launch off right away. So that's relatively new. Couldn't do before. You could basically do the same concept before, but it's slightly easier. So I would recommend looking into that if you haven't already. Right on. Cool. So let's yeah, what's up? Yeah. 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 No. No. The most amount of content I'll ever have in a repo would be like doc files with like different things like that. Yeah. So like for example, if you open up the project repo, TD Summit 2019, this is kind of a basic overview of kind of like how we're going to set up projects and how this one's going to work. And for all of our content, we're a little fortunate at AV&C. We've got a pretty big pipeline, right, in terms of like how we handle assets. There is, like you said, like the large file management system that GitHub has. Forget what it's called, where you can, essentially like link in large assets separately as a separate system. We don't use that because we have a different pipeline for how we handle assets. We have like a online thing where our clients can upload content to. It'll get automatically converted and all that sort of stuff. You definitely don't want to be putting large assets on GitHub, because I'll go through a few things, but yeah, if you do, it's going to take really long to sync things and upload things, and it'll probably fail. And especially when you're on site, your internet connection or something like that is terrible. Anyway, so I guess we'll just get right into it. Let's just start first with the super basic concept of actually installing Touch Designer. So, like, first thing you're going to find when you are working with like various projects, etc., you're going to be working with different versions of Touch Designer, because you worked with one last year as one version, then this year it's another version. So you can't really do the classic double click and install and have that work out for you too long. So basically, all of our projects we use the extract command. So if you open up command prompt, I'm sure you guys have seen this before. If not, great. But basically, you can just navigate to the directory. Let's see. And then and then, so basically, you just navigate to the directory and find the exe, and then just type in /extract. And you can also, at this point, tell it where to go in the next line. Not going to do that now, but hit that. And basically, it's going to just package out the project for you without doing the whole installer. So, again, a couple of different reasons this is pretty necessary. Is you can script this stuff out with some sort of DevOps workflow. So that's great, and it won't like prompt you with oh, is this open or closed? Do I have to close this out, etc. And then second, you can have a bunch of different projects in your let's see. So if we go to this is the derivative program files, right? So I've got a couple different builds here, right? And so we've kind of standardized off of using the exact name of the exe file as your project folder. And then you can launch up accordingly. So what this is going to do, if you don't explicitly name it and tell it where to go, is it's going to just kind of drop. Sorry, my computer's really slow. This usually goes faster. It's going to basically just like drop it with some random name. So again, you can optionally name it and tell it where to go right away. I usually don't do that. I usually just hit that, and then I'll rename it after the fact. So yeah, I would highly recommend that, and it's really easy to script out too if you need to. All right, so I'm gonna just let this play out so we can walk through it. Has anybody used that before? Yeah? And not, first time you guys have seen that? No? Cool. All right, cool. So we're
way to install experimental builds, actually, if you want to have
exactly. If you want, it's a pretty common technique. I'm sure most of you have seen it if you haven't already, but I thought I'd mention it in case you hadn't, because it's super useful, and it's kind of tucked away in the wiki, so it's, and then basically, then this is the folder, right? There it is. Great. And you can just rename it. That's what I usually do. Rename it whatever, and then you can just drop it really wherever, but I put it in the project folder. Cool. Right on. So back to the project repo. So now that we've got the, I'm going to go over basically the end goal of this workshop is to kind of give you some sense of a structure to how to organize projects to be reusable. The actual content of like what's going to be played in terms of like this kind of like a mock installation, really simple, right? It's going to be just like a movie player basically, but we're going to learn a lot of techniques to like how to structure it. And just let me know if you have any questions going along. So this is the basic structure. So once you have the repo installed, basically you can launch these things up with bat files. So right here, you're going to see two different bat files. So one here is just the path to the project, and this is just kind of like a relative path to the tow file we're going to launch. Right there. But you're going to see here, one, I'm referencing this build, and here I'm not referencing one at all. So the one, if you don't have a build on there, just going to launch up the one you installed natively. And then if you do a build one, it's going to go to the folder that you launched it up with and set it up. So so I'm going to go through all these kind of one by one later as we kind of progress through the install. But the first thing I'm going to look at is the config file. Contrast is pretty low there. Okay. So obviously, like, we're using GitHub for a reason. And as you guys all know, I'm sure, tow files are binary, as are toxes. So you really can't, just have a single tow file or like a bunch of tow files, for your installation. So one of the things that AV&C does is most of our installations are 7 different screens for some fancy person's installation, and this is doing one thing, this is doing another thing, this is doing another thing. And they're all either different computers or they're multi GPUs in one computer or whatever. So, the first thought you'd have is like, let's just launch up a bunch of tow files, and that works if you're literally the only developer. Can you guys hear me? Okay, cool. If you're the only developer, but when you have to start working with other people, it's literally impossible. So kind of the technique that we use, and really anybody that does kind of larger scale installations where you're managing more than one instance or whatever, is using a config file to launch things up. So we'll go through all this kind of as we go through. First thing that we want to look at here is this activation. So kind of the concept we do is basically create a list of our activations here. And we actually just use one config file. Some people will use multiple config files. Really your preference of how you want to go ahead and do it. But yeah, we use one config file. Sometimes they can get pretty lengthy. And you can make them as verbose or, simple as possible. But anyway, so basically we have this activations here. And in here, we're going to have all the relevant information that it's going to need to load up when you launch the project. So obviously the most important ones here are the actual tox files. So the other stuff is kind of like things we'll use to initialize to certain controllers or set up our outputs properly, name things. Our actual config files will be a lot more verbose than this because we'll have a lot of like reporting stuff and things like that in there. But so that's the first thing we'll look at here is just this part. So if you go to your bat folder here and you can just launch up this file right here. Or if you want to use a custom build, or not a custom build, you want to launch it explicitly. I'm going to launch this one. It'll launch the file up. So what this is doing, the set variable, this is an environment variable that you can inject into the Touch Designer instance. And that's basically how we look up what item in the list we are. Boom. Cool. So basically, what this bat file is doing is it's just saying set an environment variable to 0. So kind of the nomenclature we use is like a node. Right? Our Touch Designer instance is a node. And set it to 0 and then launch the file. And what that's going to do is launch the thing up. And if you go up to dialogues, variables, and macros, and then I think it's going to be built in. Should see a node in here somewhere. Or not built in. Used to be in here. Oh, well, sometimes you can see that. I don't know why you can't see it here. whatever. Anyway, usually it's there. I don't know why it's not there. Maybe it's this different build. Anyway, what happens is it launches it up based off of how you configure it. So as you can see here, basically we have our toolkit here. And basically just name it. I've got it named here. I'll go through the code, how this launches it up. We can walk through that together. And I position it, right? So I can just tell it where I want it to go within the network. So yeah, toolkit, -800, admin 200, etc. Let's see that here. Does that make sense to everybody? Yeah? Sorry? I could probably like undo the theme or whatever. Let's see. I haven't changed my theme in a minute. Oh, sorry. I should have done color scheme. Here we go. I think it's this Mononoke. There we go. Oh, whoa. I hate Mononoke. Yeah, what's up? Sorry? Oh, I see. So your Mac's not loading up the project. Oh, right. Yeah. Yeah, think about that. You can inject an environment variable via Python, but I haven't. You'd have to make a little Python script. Yeah, we could do that. I don't know if I off the top of my head I have to look that up, but yeah, I think that's like os.environ. Let's see here. Python environment variable. There you go. I think it's like os. There you go. So I think if you make a little py file and do the path name of your home directory. There you go. There it is. Ha! I knew something like that. So if you do make a little py file, and probably the first line just say that, like you can do like make that called node, and then set that to like 0, and then pull out my Python on the spot, and then I think to start up like a project, I think you just start a file like what's the Python command to just open up a program? Crap. I think it's like launch application. Say Python launch application. Start file. Yes, there you go. So os.start file, and then send it to your the tow file. So yeah, you can also do this in Python, by the way. I like bat files personally. It's a little more simple. And we use a few other things that we launch up for our sub processes when we do it at AVNC. But yeah, if you just like import OS at the top, OS environment variable thing, and then OS start file, and then direct it to your tow file, and then you run that py file, theoretically, I think that should work. Give me a holler if it doesn't. So I'm going to move on just in the sake of time here. Sorry about that, man. I didn't think about that. I should have made a py file going ahead of time. My bad. Anyway, so I guess we'll move on to, since we did the activation, first thing that I want to start talking about is extensions. So we'll start getting a little more into the weeds here. Has anyone not used an extension before? Right here? Everybody else? Great. So you guys are pretty clear what it is. Basically what it is it's a module on demand, if you will, but it's a instance of that, essentially. Module on demand is, let's just go to the wiki here in case we aren't clear. There you go. So if you don't know what that is, it's essentially just like a DAT with Python code in it, right? And you can import those, run them, but an extension is essentially like a wrapper for that, if you will. Just instantiates it, they're really easy to work with. So if we look at our project structure here, basically top down is a node, right? And if we go to the parameters on this, this is here where you create the extension. So you can have a lot per page, but anyway, this one here is basically all you got to do is you got to direct it to the node, call module on it, and then call the class on it. So here it's obviously going down into node extension and calling module on it. That's if you look at how to import these things, that's how you can do it. There's another way to do it where you can just create it. This is usually what I'll do is I'll drop it down and customize component. And down here, you can set them up pretty quickly just by launching that. And we'll just go sample extension and add it. There you go. And then if you go in here, it's going to just go ahead and create, it's going to drop that down for you and kind of set it up with kind of the boilerplate code to get going. Cool. Is that clear for everybody? Yeah. Okay. Cool. Just give me a holler if you don't understand or I'm something that hasn't covered. I assume that most of you guys already knew all that stuff. Yeah. Oh no? For any of you guys? Oh, you guys are all on Macs, huh? Oh, okay. For Windows guys, it's loading up. Yeah. Okay. Did you guys do the that py file? Yeah. If you double click the toe, just straight, that's not going to work. Yeah. You have because the whole concept is that we're like for these larger scale installations, you don't want to be using like a bunch of toes because you can't version control save those. So what that bat file is doing is it's first creating an environment variable and then injecting that into the toe. And then I was going to just go over this code here in a second of what actually is happening. So have you tried that py file? That's what you'd have to do. Yeah, that's what you have to do. Sorry about that, guys. I didn't think about, I always forget that TouchDesigner runs on Mac these days. My bad. But if you create a py file and you import OS at the top and then go and do the this right here. If you create and say os.environ and then name that key node, set it to 0 or 1, then that'll create it. And then the next line you'd want to do I already forgot what it was. Sorry? In the py file. You just be like in a py file, you just type in import OS. Next line you do and then you And then I already forgot the launch application thing. Python. What, start file. Great. Start file. And then what is it? You just kind of. So you'll start with CSV file. Then what is the thing? And this thing's located in documents. And then what is this called? TD Summit 2019. And then you, now that I think about it, you might even have to install Python at TD Summit at toe. There we go. I don't even know if I have Python on here. I do. And then TD Summit 2019 slash. Oh, sorry, this isn't download. Sorry. Okay. So that would be the file you want to create. And then I don't know if this would even work on Mac now that I'm thinking about it. And then yeah, yeah, I don't even have Python installed in this. Yeah. Huh? Yeah, yeah, it's what. Yeah. And then, huh. That should just work. So I usually don't run stuff like this. Anyone know what I'm doing wrong here? My Python. I just want to run this file. Huh? Yeah, yeah, yeah. Yeah, that's what I was doing. Python. And I just went to the file. That should run it, yeah? No? Yeah. Just run it from there. Yeah, that's what I was doing. Like this? Yeah, yeah. Thanks, man. I see. Oh, I see. Sorry, I'm A, B, and C. Huh? My bad. There, thank you. Thank you. I'm not a big command line guy, if you couldn't tell. Yeah, yeah. Anyway, so that should do the trick, but I think you'd have to have Python installed on your box, and then I think yeah, there you go. Yeah, yeah, okay, straight is, and then I don't know if the is the import OS if that's even going to be if that's gonna work, import OS. Okay, cool. Sorry guys, I'm not a Mac person. So as you can see, that worked there. So let me know if you guys if that makes sense. Yeah. How you guys doing on that? Mac guys? You're saying it's come standard, yeah? If you go to it's like Python site, and just you should be like a little download Python pretty easily and install it. Download Python, and sorry about this, guys. I should have thought about that. And then I usually just get like 3.5 or whatever, but yeah, it doesn't really matter which one you get there, since you're just doing it to launch up the file. And then you go to download. Should have different versions. That'd be great, man. Appreciate you. Cool. So what's your name? Ian. Okay, great. Ian is going to go around and see if he can help you out. Just so in interest of time, we're going to move on. All right. So basically, we're going to go through how this thing launches up, like what's the actual code, get more into the more advanced stuff here. So if you go in and you launch up this node here, I'm going to go through a few different things here. First is kind of syntax and your how you're coding. And first thing you're going to find is when you work with other people is that everybody's got a different coding style, and it can be really difficult to work with other people when you everybody uses a different camel case, underscore, et cetera, et cetera. So if you're working with other people, I would highly recommend putting some sort of a syntax guide together and try to stick to it. Kind of how whenever we hire out subs, we always give them a little document that says, please try to adhere to these things for the major, if you're using just kind of a black box, I don't really care, but if you're going to be kind of working in our systems, try to use this. So first thing is when I define classes, I'm always defining them as uppercase, camel case. And then second, we'll go into the actual how this thing starts up. So basically what an extension is a class, Python class. And what happens here is that when it starts up, the self.ownerComp it's just basically initializing this operator as its owner, right? It means that this owns this code. And that's essentially how you instantiate the constructor here with the self.ownerComp. So at any point, you can say self.ownerComp, and you're basically referencing this comp right here, right? So if I say self.ownerComp.op player, that would be this player, right? And it's always best practice to, when you create ops inside of a constructor, to do self.ownerComp, or so if I say self.player equals self.ownerComp.op this. And that's the same thing as just calling it, right? Doing like self.player, sorry, equals, let's just say op player. That's the same thing. But what's great if you do the self.ownerComp is that you can move your extension anywhere you want, and that code's always going to work, right? So that's a big difference. Is that in this little sample project I put together, all the extensions reside within their own owner, their own component. But in larger installations, when you're going to have 20, 30, 40, 50 different extensions, it becomes a little unwieldy to go to a bunch of different nodes, so you can put all your code in one place. And in that case, you always need to know where the extension's component lives. So when you create these things, always do self.org.comp.op if you're going to create any attribute. So is everybody familiar with like attributes in Python, right? Yeah, somewhat. So an attribute in Python is essentially just like a class variable, if you will. Just essentially, like, for example, parameter would be like an attribute of an operator. And so when you initialize these things, you can create as many attributes or properties as you want. It's really a smart thing to do because you're creating an instance of it, and also you're putting it into memory. And it's a lot, not a lot faster, but it can be faster to initialize these all once as opposed to calling your ops every single time. So anyway, so this startup, how does this work, right? So first thing we do is store all of our activations, right? So what I've done here is create a storage manager object, and this is essentially just a wrapper for storage, op storage. Everybody know what op storage is? Yep. So op storage is just storing data within ops. So if we look here at this here, I mean, inspect it. It says node extension stored. You can launch anything up there. Op.store, put any sort of variable in there, and then you can access it with like op.fetch or however. But in this situation, I'm using a storage manager object for visibility and B for stability. And so a storage manager object. Everybody know what a storage manager object is? Anybody used that before? Let's go. They get it all set up there?
Yes.
Great. Awesome. So you guys are launched up now? Great. So this is like essentially a storage manager class. I use it from time to time. You don't technically need the storage manager object. You can just use op storage or just like properties within the class. But the benefit of this is that it basically, like, you don't have to. It'll be persistent across saves and reinitializations. So it'll actually save stuff into your TOE file. So you need to be careful with it. But the benefit of that is that if you're reinitializing and you're developing, it'll stay there. Cool. So what I do here is I call storage manager, and in order to put stuff into storage manager, you basically need to pass in a list of dictionaries. And so that's where I call this load config here. So basically here, what I do is I call store config, and I pass in the load config here. And if you look down here at store config, basically all it's doing is it's going to the config, which I passed in, and basically slamming through the, I'm not going to go through all the details of the code, but you can look at it later. But moral of the story here is that it's just going through all the keys in this config. So environments, hosts, activations, and it's storing them into the op storage for you. All right, so basically 4 key val configs, and then I just append here I append to the list a dictionary where I pass in the key and the vals. So all that's doing basically is it's dumping into the node storage your entire network. And so the whole reason we do this is that now you've got all this stuff available as not only properties, but op storage. So basically now you've got your entire activation, all your different nodes in your network for you to access and use, right? So pretty simple in this scenario, but pretty powerful when you have 10 different installations and you need to randomly access some sort of variable from one of them, right? That makes sense to everybody? Yeah? What's up? Yeah. Oh, yeah. All right. I'm sorry, guys. I should have thought about this. Don't worry about that. That's just icons. So, yeah, did it still start up, though? Okay, so but you got the tow file and everything going up? Great. Yeah, yeah. It's probably the it's probably it's actually the SVGs. You can just take those out of the. All that does is these little icons. So you can literally just go into each of those nodes, just undo the expression in there. Yeah, you'll be good. Yeah, you don't need it at all. That's just there for makes it look pretty. Cool. So yeah, so that's like the very first concept is just launch up your project, load up all your data, and have it accessible throughout the network, right? So that's a lot better than, in my mind, storing a bunch of tables that you have to look through. You just basically got everything there. Cool. So that's what that does. And then after that, basically what I'm doing is here, we've basically got this node stored object, and this is a property, right? So actually this is a property since it's a storage manager. And then I just add like the IP and stuff into it, right? Cool. Right on. And then the second thing that happens after that initializes is what happens is this load node gets loaded here. And this load node, all this does is it just goes through what we've just loaded, and it just opens up all the tox files. Make sense? You guys doing better over there? Right on. All right, so basically now that we've got the project loaded up, I've got this secondary function here. Is sometimes when you're working with loading a lot of toxes and a lot of subtoxes, you'll have initialization problems, just because they're not cooking, your extension's not initializing. And so one of the things that I do quite often is like use tags. So in this case, I've got an init tag, and on all the components that I want to make sure initialize properly, I'll put this tag on there, right? And tags are a great way. I don't know if everybody use tags. They're pretty common. And basically, you just throw a tag on it, and then easy enough. You can here you can just search through. Basically, self.owner comp references the node container, and that's basically root in this case. And just find children with all of them that say init, and then I just go through and slam through, and I initialize them all. So that's basically guaranteed that things you need to initialize will initialize. So in a perfect world, they would initialize. Unfortunately, sometimes it's not a perfect world. You got to manually do it. So I found that to be really useful, very explicit. So yeah, that's basically the startup code, guys. I'll go through some of these other properties in a little bit, but that's basically how it starts up. Any questions? All good? Cool. Right on. So then I suppose the next thing, now we've done that, is after the external procedure, environment variable, storage variable, start looking at some tools. So next thing you're going to want to know and have available for you is tools that if you do it once, make a tool out of it, right? And just continually use it over and over and over. So and in that case, you want that to be reusable for all your projects, right? So first thing that this is kind of like a real small version of a toolbox that we use. Maybe you'd see we have a lot more, but in this case, I just made like some real core ones, and these are really useful. I mean, you guys can. I would recommend looking at these, using them. Super useful. They're all iterations or variations of things that have been out there before, but kind of my own spin on them. So first thing is I'm going to go through is this external sync. Basically what this does is that you can externalize a file very quickly and easily. So when you're programming, obviously, you've got these toxes, they're all externalized. Well, you can only, if you move a node, boom, your binary file's changed. So you can't really version control that. So outside of that, that's why all of our files, if we're using extensions or whatever, we externalize the files as well. So first thing to do, what I've done here is you can basically like create a text operator, and then hit Control E. Sorry, Control Alt E, and then it'll basically like prompt you through a bunch of stuff. So if you want to create a new external file or create one from an existing, whatever. So I'll create a new file here. What type of file do you want to externalize? Pi, GLSL, JSON, whatever, whatever. And that's not the only ones you can do. You can go in the code and change all that. Pi file, boom. And then basically what it does is it externalizes the file for you. Let's see, boom, Pi. So what it'll do is it'll create the file, it'll create the folder and file for you if it doesn't exist automatically, and drop it in there for you. Boom, there you go, you got it. And then what it'll do is it'll make the file for you and do some nifty little things like putting the custom extension on there for you. What that does is it allows you to just like automatically open it up, and it's open it as a Pi file in your external editor. So that's somewhat useful. And then what I do is any file that's externalized, I colorize a color, so you quickly know that it's external. So that's basically that. And then up here you have some parameters, external file color, whatever, and then it just flashes the screen to know that you've saved it essentially. So that's pretty useful. So, and again, this is all just an extension. So you feel free, like I said, you can go here, anywhere in here, you can add some different extensions in, that'll work with that. And then it just basically spams through and does it all for you. Real simple code, but really useful. So that's the first thing you want to do. What's up?
When you delete a file, does it?
So yeah, the one that I use primarily does. I didn't want to do that one in this one, just because you got to be somewhat careful there because the first round of me building that, I did do that, and then of course some bug in it deleted all my files. yeah. So you can do that. I would just recommend being careful with it. That's another good reason why you version control, right? If you delete all your files, you can just get them back. So it's not that big of a deal. I didn't want to put it in here for you guys, but basically to do that, you got to crawl through your directory and delete the file, match it, blah, blah, blah. So the code was getting a little annoying, and I just, for the tool I wanted to give you guys, I just want to make sure that worked and didn't mess around with too much. But yeah, one version I do does have it. Right on. If there's anything in here I want to let you guys know. No, that's about it. All right, and then the next one I have here is this external talks. And this one obviously has been a bunch of tools out there to do this. It's going to be my version of it. Basically, if you hit Control-Alt-S, what it'll do is I just wanted to have one shortcut to do it all and not have to remember what keyboard shortcut does what. So this one has two. First one is if you just do Control-Alt-S, it'll just search the entire parent tree for any external talks file and ask you if you want to save it. And then second, it'll always ask you your parent container if you want to externalize it or save it. So in this instance, if I had this file here and I went inside it and I hit Control-S, it's going to ask here if I want to, even though this isn't external, it's going to ask if I want to externalize it. So that's just one button you can do anywhere up, and it'll list out all of them for you. So that's pretty useful. And then the second one is Control-Alt-D, and that's going to go through from parent all the way through your entire network and ask you to save any external talks that's been changed. So as you can see, yes. Right, so I had two unsaved talks files, and it'll save it for you. And then this little guy here is just something I want to talk about with you guys. So another thing you're going to find when you're programming is that often you need to launch different functions based off different criteria or whatever that may be. And when you program, a lot of times you'll say, if this statement, this keyboard command equals that, or this or that or this, then do something. Probably not the best way to do it, because not only can you not really config that, it just really becomes really cumbersome with a lot of code. So what we've done here is a really useful technique using dictionaries and looking up keys. So basically what we see here is when I initialize this key callbacks, basically this is a run delay. I'll go through that in a second with you guys. But basically what I'm doing here is creating a key. So in this case, E, S, D. And I'm basically putting a function there as the value to the dictionary lookup, right? So when I hit my Control-Alt-Key, right, what I do is I call this dictionary, and I pass in the key. I hit that, and basically it just runs that function. And then here I pass in self.ownerComp, and then it basically just goes here and finds the right function, right? So does anyone not understand how that called the functions? I'll explain what happens there. Basically what happens is that when you create a extension, right, what's going to happen here is that if it's so in this case here, any function that you create in your extension that's capitalized is going to be essentially a promoted function. That means that you can actually access that function outside of the class. So you can call that class from anywhere in your network, right? So basically what that means is that, let's say I had a script in my network. Well, if I just wanted to run that script, I would have to navigate to whatever relative directory it was, run the script. But in this case, what you can do is you can just call the owner of the extension and just hit it. So if I went like, so I just went like this, file, right? So if I ran this file, if I ran that function, that would essentially do the same thing as me hitting Control-Alt-E. That make sense? Great. And then secondly, if, for example, this was lowercase, that would not run. It wouldn't be able to find it. So that's like essentially a non-promoted function, and you wouldn't be able to run it. And I'll go through some of that stuff here once I go through some other code here. But one thing that we're going to talk about here shortly is when you work with other programmers, sometimes you're going to want to have code that just does stuff that they don't need to know about. And in that case, we can use hidden functions, non-promoted functions, and hidden attributes that do stuff for us without them having to know, and nobody has access to it. So it's kind of a higher-end concept of like object-oriented programming where you don't necessarily need to expose all the data to everybody. Cool. So that's the external sync thing. Really useful. Feel free to use it, extend upon it. Like Ian was saying, yeah, roll your own, but it's a good little base for doing it. Cool. So the next one I want to talk about is logging and reporting. So as you can probably see in my little text port here, there's been some stuff printing out, right? So basically what I'm using is what we've kind of used as a standard is the native Python library to log stuff. And basically it's pretty powerful, right? Because you can essentially define a logging profile that does different things. And so you can basically call one line and it'll do like 8 different things for you, right? So for example, let's say I want to have something print out to the text port, but I also want to log that thing to a file, right? If you didn't use the native Python logging or you didn't roll your own logger, you'd have to have, relatively complex little, class or something that does that yourself. Whereas with a logger, what we can do is you can define handlers, different handlers. And a handler basically just says, where do I want to send it, right? So I'm not going to go too deep into the Python logging, but you can create a file handler. You can create a socket handler to send information out over TCP/IP. You can create a text port handler that sends information out to your text port. And then you can create filters, which are just like, let's say you've got some sensitive data that you want to use that you don't want to have in there. You can basically pass that information into the filter and it won't log for you. And then the formatter is another great one. So let's say I want to be able to send like JSON out to a reporting service, or I want to do JSON to a file. The log itself isn't going to be JSON, so you'd have to format your own. So I'll show you that actually. So I created a little one for you guys here. So this I do kind of want to go through some of it with you guys. So to create a logger, basically, hold on here. There's a couple different ways you can do it. You can just manually define it without a config file. I don't like doing that personally because you can't use a config file. But basically the moral of the story here is that you can create a logging dictionary config, right? In this dictionary config, you can define your formatters, your handlers, your anything you need in there that's in the native Python library. So if we look at this one here, basically what happens here is that there's only one version ever. That's what you need. And then disable existing loggers. That means if you've got loggers already existing, it'll override these and only use this. Anyway, so basically what I want to do is I want to create, in this scenario for this installation, I want to create two different loggers that do two different things, right? So in this case, I'm going to create two formatters. One formatter goes to the text port. The other one goes to file, right? And then basically how this works is that you pass it a string of what attributes you want to grab. And that's going to be basically these guys. If you go to log record attributes, whenever you call your logger, it's going to just automatically grab all these attributes natively. So you can get a bunch of information like your trace report, your time, your module, the message, anything that's here, right? And so then what I do here is that these are the ones I want, and this is the format I want them in for my timestamp. And then here on my file, I want the same information, but instead of using the native handler, what I want to do is I actually want to use this this JSON formatter, excuse me. So here, what I do is I want instead of using the native formatter that would just print out like strings, I'm going to make it JSON. So this is basically how you configure it. I don't want to go. This is a pretty deep topic, so I'm going to just show you the code, and then you guys can look at it later. But basically, this is how you set up your formatters. Second, you have handlers. So since I want one handler to go to the text port, that's called a stream handler. It's basically sent it to your system out stream, right? And then basically you just say what formatter you want to use. I'm going to use this text formatter. And then the stream here, I want to use just like the system out stream. That means it's going to send it to your system out std out stream, which in this case is our text port. All right. Any questions so far? I know this one's it's just a straight config file. So unless you've seen the format before, it's a little odd, but I would recommend looking at this later and maybe getting an idea of what's going on. But moral of the story, you're just setting up a logger. And I'll show you how to use it here in a second. And then second here, I've got another handler called file handler. And here I'm going to create a timed rotating file handler, right? And so what this does is that you're creating log files. You don't want to log them forever because you're going to start getting like multiple gig log files, right? Like if you log for 2 years creating text files, all of a sudden you're going to run into the situation where you've got a 2 gigabyte, 100 gigabyte log file that you're trying to sync to GitHub or whatever. Not a good idea. So you could either ignore it on Git or you could just rotate logs. And so a lot of times it's a lot easier just to rotate logs. And what a timed rotating file handler does is it just you can config basically like how you want it to roll over and how many files you want it to save, right? So it's pretty nice. We use this basically here. These are all the I've made a little component here. These are all the variables that you can use to essentially rotate seconds, minutes, hours, days, every Monday, midnight. So that's your win, and then your interval. So pretty self-explanatory here. So if I say days 30, basically what's going to happen is that every 30 days, it's going to roll over, right? Great. So you never have to deal with too many log files. And then this is how many backups it's going to keep, right? So if you look here in sort of our py file, in sort of our here, let's see, log. There you go. Look at that. We've got our primary here, and then we've got the rolling backups here. I just created these using like seconds as the interval, just so I could show you here. Basically, I had to like roll over every second and create 3 backups, and it'll just create it for you there automatically. It's great. So very, very useful here. You can also set the level warning here. So, so now that we've got the logger configured, basically here I just pull the parameters for what I want to pass in, and I name it using this string. And then down here, this is how you basically create the logger. You've basically configured it here, and down here you create it. So basically here you say logger. You can create a bunch of different loggers, but in this simple example, I'm going to create one logger that all the other modules are going to inherit from, right? So we have one logger that sits at the very top, and every single module is going to use the settings for that root logger. So in this case, the format for that is just to define it as a blank string and then tell it you want to use the text port and file handlers to use your just root logger, right? And then the level is at what level do you want it to trigger events. So this is where it gets a lot more interesting. So, and then down here is the last thing. You gotta call it. So basically, this here just says run delay, right? Logging.config and pass in loggers. So basically, all this does is it just calls dict config on the logger and it initializes the logger. So now you've got a logger. How do you use the logger? Oh, actually, I wanted to show you this JSON formatter here. I use a custom formatter, and then what I do down here is if you look up the documentation, you can actually just look at, you can just override the native methods, right? So the native method of the formatter object is this format. So anytime I use this JSON formatter, I call format, it overrides the native function, and then I can roll my own code. And in this case, I want to roll my own code called format JSON, which takes the record, which is native, it just passes into the logger, takes the record and slams through them. And if the record exists in this string here, it'll store it for you. And then instead of just dumping it out, it adds some stuff and creates it as a JSON file, right? JSON format, and then returns that JSON format. So that means that whenever I call my file handler, instead of it being a string, like just a boring string that will show, like instead of a string that's like, actually I did it to the text port so you guys could see. So any text port thing you see, it's going to be a JSON as opposed to a file string, which has 2 benefits. A, it's easier to read. You can dump it out to the display, all pretty. And then second, it's a lot easier to organize and search through log files that way. So at AVNC, we've got like a reporting system essentially, and you can automatically search through logs based off different keys. So it's a lot easier to do that with JSON than it is to do it with a bunch of strings, right? So yeah, a lot easier. Anyway, so let's go here. So basically what this is going to do now is that when the project initializes, it runs that code, right? Because this is, if I go into this toolkit here, log, right? When this is in the initialization of the extension. So when this code initializes, it creates the logger for you, right? And when it creates that logger for you, that means that you now can grab that logger anywhere in the entire code base, right? And so to do that, real simple. Import logging, right? And then logging.getLogger, right? So logging.getLogger, you don't need this technically, right? So when you do logging.getLogger, what's going to happen is it's going to search your entire tree and find all the loggers you got, right? And in this case, because that's what the logging module does, is it creates a hierarchy of different loggers that will search through, just like if you just went straight up through like a parent tree. And so it has a lot of built-in functionality that you can use to use different loggers. So in an advanced system, instead of having one logger, you could have a logger for, you know, this activation or this activation, and they can all be different things. And it's very easy to set up, and you can even set it up with a JSON file, right? That code I just showed you here, that can be a JSON file, and you can just load the JSON file, right? So it's a lot easier than having to deal with, you know, I wanted to put the code here because I wanted to throw in custom parameters into it and stuff, but you can configure it. So anyway, so what this does, when you do name, like that, what that's going to do is it's going to like create an instance of the root logger using the name of the module, right? The name of the module. So in this case, let's go. Actually, here. I'll show you here. So what I did here is I set this some weird timer bug where you have to like go through the entire timer before it changes the. So what happens here is I've created a little reporting system here, and what this is doing. So this is essentially like a little monitor tool that's really quite useful. That basically what it does is it just, this is like a very simple version. In our systems, these are expanded out quite a bit to report to different services. But in this case, all it's doing is it's just creating a little heartbeat for you and different information. And here, what's happening here is that I create the logger, and then every time this hits, what I'm doing here is I'm doing parent.monitor.heartbeat. So what this is doing is grabbing the parent shortcut of the operator called monitor. So everybody know what op shortcuts are and parent shortcuts? So an op shortcut, you can just do op dot the shortcut from anywhere in your network, and it'll grab it. Whereas the parent shortcut will only search directly up the parent tree. And so what I usually do is if I'm inside the component, I'll always use the parent shortcut. It's searching through less objects, objects. And then if I'm outside, I need to reference something outside the parent tree, I'll use op, right? So what this is doing in this scenario is all it's doing is it's going to the parent here, and it's calling heartbeat. And so then all this does here is creates a little dictionary. So this is actually another clever technique. So when you're programming these installations, right, like storing data and handling big data sets is basically exclusively done through like dictionaries and lists and huge data structures. And so this is a very simple example of how you can create a data structure based off your operators inside Touch Designer. So what this does is it goes through and self.perform monitor is just referencing this operator here. So self.perform basically just references this guy, right? And then what it does is just basically goes par.par name for par in here. Basically, there's a for loop that creates one item for the channel name, and then it puts the value in there. So basically what it does is it creates this nice little dictionary for you. And then what you'll note here, and this is really where it gets powerful, especially when you start developing out, is that all I got to do here now is do logger.info. Okay, and so this starts getting into like the fancy stuff that gets a lot more interesting. Is we've defined this logger, and loggers have 5 different levels, right? Debug, info, warning, error, and critical, right? And so inside your config file here, inside of here, you can define what each of these are going to report at, right? So in this scenario, I want this to report at debug, and then over here, where I put on the level here, right? So here in the level, I've referenced, I put it to warning, I think. Yeah, warning, right? So that means that when you hit, let's see, where am I at? When you hit logger.info or logger.debug, logger.warning, it's going to trigger at different intervals, right? So in this case, I want to do, if I did logger.warning here instead, that would not trigger my text port handler, right? Because the text port handler is an info. So it's only going to trigger an info, whereas logger.warning is going to go and it's going to hit the file handler that's at warning. So anything above warning, error, critical, it's going to log to a file, right? So that's where it starts getting powerful, is that when you're initializing or you're running live productions with real-time systems, you need to know, like, I don't really care if a message came in. Great. I do want to know if, like, the JSON's bad and it errored out, right? So if that happened, I'm going to do maybe logging.warning or logging.critical and have a separate file handler for that, or even a socket handler, and say, oh, hey, like, raise your hand and be like, hey, something just broke, right? And then you can start thinking about how that becomes powerful using JSON and creating a bunch of log files and being able to search through those log files quickly and easily. There's a lot of tools out there that you can, a lot of tools out there that are pre-built, kind of turnkey, that you can just dump log files into that you can search through really easily and quickly. And so it's a lot better than just like a couple of print statements, right? So anyone have any questions on that? No? Cool. Yeah, that's a lot. I know I just talked a lot there, but it's kind of a deeper topic and kind of takes a little bit to wrap your head around if you've never used the native Python logging before, but it's definitely something really powerful, and I would definitely suggest checking it out. Really easy stuff. You just go to the Python site. The documentation is quite vast. There you go. So there's your different levels right there. Quite vast. And you can, like I said, you can roll your own handlers, formatters, and just override all the native objects here. And basically, like a lot of the work's just kind of done for you, right? Great. Cool. Yeah. No. You could do that and create a watched file handler where you were looking at a file and looking at a certain folder and looking for changes. You could definitely do that. I bet some people do that, in fact. Network-based. Yeah, I can show you here. So what would happen is that, think about how this would be used, right? It'd be used in a situation where you have an installation running and you're getting data that's coming into it all the time, right? Like some installations you just kind of set up once and it just plays a video and that's it. Whereas in a large-scale installation that's real time, you're having data that is changing at all times. So for example, in AV&C's case, we'll get to this a little bit, but we have a thing that is essentially the controller, right? You create shows, and like on some website, you create a show, and it has a bunch of data, and it sends that to you on some schedule, right? So like we can kind of go through it here, like in this scenario. So nice segue, actually. So basically what will happen is like, we'll have a thing where, like, let's say this is an installation. This is like a little mock installation we can take you through. Very simple, but it's going to demonstrate a lot of core concepts that can be scaled very, very easily to very large installations. So this is like a little fake video player. Sorry, my computer is really bad. Forgive the frame rate there. Yeah, that's funny. So this is like a little mock installation. Let's say that we have an installation where we have 4 different screens. and one is two are 4K screens, and two are 1920 by 1080 screens, right? And we want to send information to those screens at different intervals. So like they're on their own schedules, right? And we're going to want to change the video for screen A at this time, and we're going to change video for screen B at this time. And they're different, right? So you need to be able to handle that. So to answer your question, let's say somebody sent me a bad payload. Preferably, you'd have all that handled beforehand with some sort of JSON validator. But in the real world, you're going to get bad data sent to you at some point. And if it errors out, what do you do? Well, how we would handle it is that we would have different code. So, for example, I'll go through this shortly in the communication, but just to answer your question here, we have essentially a controller object here that receives data, and then we have a bunch of error handling. So error handling is your friend, and this is not quite exactly what we use, but I made it real verbose, so it's very clear what's happening. And basically, it's a lot of if-else statements and try except handling. And so if anywhere in here, like let's say I have a command that comes in wrong, or a type that comes in wrong, or bad JSON altogether, like it's formatted incorrectly, or it's empty, whatever. You can even go further than this. What it'll do is it'll hit this logging.error right here. See this? Logging.error. So I've got my, when I imported this, right, I imported the name. I imported my root logger. So that means I've got two logger objects. I've got a file handler object, and I've got a stream handler object. So if I say logging.info, it's going to go to the stream handler. If I go logging.warning or above, it's going to go to the file handler, right? So I do logging.error, boom. What happens is that file is going to get logged to disk instead of just to the text port. We'll do both, actually. And then what we would actually do is have a socket handler or a separate service that sends that out and say, oh, hey, this just aired out. Send it to some reporting service. So this is another benefit of working with a company that has other resources than just yourself. So when you're working on a small installation, you're not necessarily going to have some sort of off-site reporting service that's going to monitor this stuff. But you could have a file handler and roll your own. But we would have a thing that says error, sends an alert, and we've got it all set up to where it comes into Slack, sends emails, like so you know. So the whole idea is that you know before the client knows, right? It's a little embarrassing when the client has to reach you out. So hopefully you can solve these problems quickly with logging. And also, you'll find that a lot of times you don't really know what's happening when your things are crashing. So if you don't log stuff, or you don't have some sort of way to track what is happening, so that's why these logging statements are in there, right? So that if something is crashing at whatever time every day, well, usually you can go back in, turn on your logging, and see what's happening, and try to figure that out. And hopefully you've created it in a way where you don't have to figure it out, right? Somebody else can figure it out, like whoever is supporting on the project. Cool. So anyway, that's a good segue, I think, to the next kind of probably more fun stuff for you guys than loading a project and looking at logging, because that's the boring stuff. But again, the whole goal of this talk is to show you concepts that aren't necessarily utilized by a small one-off installation, but more of like if you're going to develop in a way that other people can use, then yeah. So the next thing we're going to talk about here is if I want to create some sort of object for somebody else. So we're going to start talking about how to work with other people, versioning and stuff like that. So let's say I've got this nice project structure and everything, right? It's all great, but I'm busy and I got to hand off some work to somebody else. So I'm going to hand off some work, right? And you're going to have to program something. And I'm not going to know what you're doing, right? But I want to set you up for success, right? So there's a lot of things you can do here. Basically what I do, and we use a lot, is creating modules that do the things we want to do, minus the small things that are going to be specific to that project. and hook that person up with those things, right? So in this case, I've got a little admin talks, and in a perfect world, we'd have this, let's say you don't trust the person, right? So hopefully you work with people you trust. But anyway, so you can add privacy here, right? So with the pro license, you can add privacy to this thing, and no one can get in it without your password. I didn't put that on here just so you guys could access it, obviously. But so in this installation here, we've got two 4Ks and two 10Ks and or two 1080s, and for the sake of the installation here, the workshop here, I crammed all those into 1920 by 1080. So we're dealing with like 960 by 3. So I just wanted to create stuff you guys could use. And this is a situation where we have 4 activations within the one. We have 4 screens within the one activation. And I want to control all that with a movie player. So I go into this admin here, and I want to basically create a module that the other module can use without having to know anything about the code. So basically what you can do, go ahead and create that module and go in here and create a module on demand, right? I'm going to go ahead and start showing you the proper way to do this stuff. Oh man, you got me on this new whatever this theme is. Oh, sorry, wrong one. So inside your external editors, this is really the only way I would recommend programming is through an external editor, through a folder structure. Once you start getting a lot of files, because it really makes your life a lot easier. So basically, if you go to your control, like Sublime, Visual Code, whatever, usually you can just open up a folder here, and I'm going to just open up the entire project. There you go. So now you've got your entire project at your beck and call here. And it's a lot easier to just, go like this across your entire project than navigate around constantly. You know what I'm saying? So highly recommended to use this way. So I'm going to just start doing it this way. And of note, this used to be kind of not very feasible to work this way because it wouldn't sync to your operator and touch designer, right? So it would, but it wouldn't be reliable, right? So you hit save here, saves the file to disk. Oh, great. Well, the file's saved on the disk, but it's not pulling into the actual DAT or text operator in touch designer, right? So that used to be a big problem. So back in the day, I had a little wrapper that did this. People have come up with different versions, but this sync to file option, this is something that I specifically asked Derivative to add in myself, and Selena just put it in last build. So this sync to file is pretty money. Basically what it does is you just turn that thing on, and if you make any change to that file, no matter what, whether you make it to the external editor or to the DAT itself, or from your folder, whatever, it's always going to be in sync. It's always going to write to the file both ways. So if you're working with external files, that's the only way you should be doing it going forward. There's a small problem with it in the official build, but it's fixed in the new RI. I've been rolling this other build here, this 18360. It's fixed now. So the next after the summit, they're going to push into official. Use this going forward, and that's actually something when I do the if you use this little tool here, and you do the Control-Alt-E, and whatever new file, it's going to just do that for you automatically, right? Just turn it on for you. So that's nice, and you can also see there, like if you use this external editor tool, it makes your life a lot easier. If I say new file, this one, oh, it already exists. You want to override it, so. If you use that thing I built, it'll make sure you're not overwriting files. It'll prompt you and all that stuff. So anyway, so let's dive into this a little bit. So let's turn this off. So I'm just turning off the monitoring for this, less busy. We're going to want the tech support here. So in my admin here, I've got this player, and the whole idea here is that I want to be able to, let's say I want to like create a player component that does all the loading of media, all the cross-fading of media, all the handling of the different decks and whatnot. So basically here I'm going to walk through a few things that are pretty helpful. In particular, how to use properties in Touch Designer, and in particular how to link parameters with properties, which becomes quite valuable. So in this case, I've got a little player component here that I built. Basically, I use the storage manager again, and I'm going to show you another method. So one of the things we want to think about in Touch Designer is like how do we store data that comes in, and how to use that data, how do we send that data around, and how is it visible? Because when you use a table, it's very visible, right? You've got all your data in the table. It makes sense. But like I found that using tables and stuff like that, when you're working with a data set that's ridiculously large, makes no sense at all. Because you can't, let's say you've got a payload that's got 10,000 items in it. It's going to not be the best to write that to like a table dat, right? So what you can do is you can store those things as attributes or properties to your extension, and you have access to all those very easily in the network. So think of attributes, in particular promoted attributes and properties as data holders, ways you can hold data in your network. And yeah, that becomes really powerful because you don't have to deal with parsing out a bunch of code, essentially. So in this thing here, I'm going to show you a few things. So basically what I've got here is I want to be able to just say for any user that can easily define where their files are located. So in this instance, let's say I hand this over to a dev, and they need to program, and they need to develop, but obviously they don't have let's say there's going to be an asset path on the target machine, the final machine for production. They're not going to have that same drive structure necessarily on their own machine, right? So that's where the config comes into play again. So if we open up our little project again, if I go to the config, see there's your binary file. That's why you don't want to save binaries. Anyway, so here, check it out. So when we launched up the project, we stored all these objects as a property that we can access. So in here, what I've done is basically when the project started up, I looked for the host name of the machine, and boom, there we go. What it did is it created my asset path to whatever I've defined here, right? So let's say my on-site developer wants to send this to his desktop, or if you guys even want to try it, you can add your host name in here. Basically, you just add your host name there, and in the asset path, you direct it to a folder of assets. Boom. And there you go. So now whenever we run this component, it's going to be looking at those assets. Yeah, so very helpful technique there. But anyway, what's useful about it is that let's say that I don't want that person to touch these things. I can define that all here, and he can't touch it. And if I want to send default media in, boom, right there. Number of decks, crossfade duration, and image duration. I can set all that here on this component, right? Lock it, right? And no one's touching it going forward. So pretty powerful feature to be able to do that. So let's walk through some of this now. So on this component, I've got these parameters, right? But what I want to do is I want to essentially create callbacks for these parameters, right? And so obviously the obvious way to do that is parameter executes, right? Where if I change a parameter here, it executes stuff, right? So that's kind of a bit cumbersome when you start dealing with a lot of a lot of operators. There's really two ways to do it. You can do the whole if par.name equals thing, or you can do the preferred method. Should be right here. So this is a way that actually, if you go here, they added this in recently, which is pretty nice. Let's see. Is it here? And then so if you go to the palette here, this UI basic widget scripting, they were nice enough to finally add this in. I don't know why it's never added in before. Huh. Nice. Oh, sorry, I'm an idiot. I don't use the widget or the palette very much. There. So basically, what this is doing is it's like essentially a catch-all, so long as you set up your network right. So obviously, like when you're programming in Touch, you're gonna have to be executing crap from parameters and components and pars and all that stuff quite often. And if you don't want to just go through some long rigmarole of catch-alls, this is really nice because basically what this says is it creates a comp variable here, meetup.par.op. So basically it says this guy right here, right? So it basically grabs that, which is the component itself, and then if it has the attribute name, par.name. So if it has essentially a function or property in there, if it has an attribute, if the extension or whatever you're referencing or the component has a property or attribute, go ahead and get that adder. So get the attribute of that name and then run the function, right? So this is like, essentially what this is saying is parent, whatever the parent is, if it has the attribute name, call it, right? Call the name. So that's the polis and par. So basically you're just calling a function of the same name of the par. Does that make sense? Yeah? Yeah? Okay, cool. It's a little, I don't like how they write it here, but I'll show you what I do in mine. So in this case, I've got this code here, and I've got these properties set. So a property is essentially like a way to, lots of different ways you can use these things, but yeah, property is essentially a way you can run code, get values and set values of code without having to expose them to a user or like as a function in your class or something like that. So they're used a lot. Oops, sorry, my mic here. They're used a lot in object-oriented programming. But in this scenario, what I'm using these properties for is to get a value, and then whenever I get that value, automatically run code, which is pretty powerful because it's essentially a par callback for any parameter. And I would highly recommend if you guys if you're not going to one, I don't know what, Keith Lestracco, he's doing a presentation on multi-GPUs, and he built this whole wrapper that he's going to talk about called par properties wrapper. It's pretty epic. Hopefully Derivative's building it in, but it's essentially a wrapper that automatically creates properties based off parameters and serializes them in a way, creates them in a way that are serializable so you can send that stuff across networks. Which is pretty epic. So you could, in multi-GPU installations, you need to send information around. You can basically create a property. Let's say you change the parameter of a play value, and you want that to send across your whole network. You just slide the thing, and the property setter automatically just does it all for you. It's pretty epic. This is a small version of that. And so with this player, I wanted to show you different ways that you can use attributes and properties in a real network. So in this case, this is the player component that I've exposed to the user, right? And this is the player module that actually does everything. All right, so if we look at here, inside the player mod, we've got a load media function, we've got a preload function, we've got check preload, make sure it's preloaded, we've got play, validate file, right? So we've got a full component here that does everything that necessarily you wouldn't want to have somebody else program because you already did it. So what happens here in this is that whenever you change this deck number, right?
creates a number of decks for you automatically. So what's happening here is that whenever I change this parameter, decks, so I'm going to walk through this kind of slowly so you guys understand what's happening here. So if I go to my player mod, I've created this player, and I want to have my user access everything in here, have access to everything in here without actually seeing it. So I'm going to go to my player component, right? And I'm going to go to this extension here. So here, I'm in the player component. The key thing here is I grab that whole module. So here, that player component's a module, right? It's a class. I want to grab that class. So that's what this line up at top does. It says mod, which is essentially the internal touch way to grab a module, and it just routes to that module. So op.playermod.op.playermod, .playermod, a lot of player mods. Basically, it does here. It goes to op.playermod, .op.playermod, and then the class is player. Does that make sense how we imported that? Yeah? Feel free to say if you don't understand. All right, great. So basically, this is called inheriting, right? So basically, you pull the class there. And so now, if you want to inherit from that class, you can create a new class and say player. And you just pass in the player as an object into the new class. So with those two lines, what you've done is you've allowed this player extension to have access to every single promoted attribute and property, as well as every single attribute and property in there, right? So that's great. And then the second thing you need to do is actually override the constructor. So this constructor here is, right, so this is the local constructor for the class. This constructor here basically says player, which is the module, dot init, and then we pass that in. So basically what that does is it pulled in and overrode your local constructor with the class constructor. So all the code from this guy, so all these attributes here are available for you in the other one, right? Does that make sense? Cool. So in this scenario, it's basically all it is a simple A/B deck player that you can send different shows to uniquely without them interfering with the load media, all that sort of stuff. So and then here also, so that's what this code does here, right? So this is what I was going to show you, is that how do we use these things and actually pull them into the network and use them, right? Because we got these abstractly in code, but I want to actually get that information into the network and use that information. And so this is where using these different attributes and storage and things like that become pretty powerful. So, excuse me. So when I call that, what's going to happen is that, so when I go here, this deck count, right? So, better be slow here. My computer's not the most powerful. So when I change this deck parameter, what's going to happen is that it's going to create new decks for me automatically, right? And as you can see here, what's going to happen is that it's going to create each slot. An A/B deck has an A slot, a B slot, right? So it's going to create each deck as properties for me to grab within my network, right? So what I'm doing here is this is an examine dat, and it's just grabbing, just looking at my extension here, and it's looking at trying to find any key or a property that matches this string here. So that's what's happening here. So in this scenario, we have 4. And so this is the powerful thing I wanted to show you, is that you can pull these things in quite easily, right? And then what's powerful about this module inheritance is that, let's say I want to let the user give this access to it. Well, you can do things like make it read-only. So I don't want the user to be able to actually adjust the deck number, right? Because we know it's going to be 4 installations or whatever it may be. So they don't have access to this. Now, a smart user could just disable read-only, right? But let's just pretend they don't know what they're doing. But how this works is that whenever you call this stuff here, or excuse me, whenever you call this stuff from here, like if I change this, right? What's actually happening is we've got a parameter binding to the admin, right? So if I change this here, what's actually happening is it's changing the property on the master, right? Changing the property on the admin module. So you've actually updated the value here, right? And you actually haven't updated the value. Well, this is reading from the module there. So the whole moral of the story here is that I create this for somebody. I don't want them to have access to change the asset path or the default path or the deck number, but I do want the user to be able to change the crossfade amount or how long like an image lasts, right? Does that make sense? Right. So, next part. So, now that we've kind of understand that this deck player we're creating decks on the fly. Well, that you're the user now and you want to start programming stuff, right? Well, you've already got the deck player made for you, and then you can extrapolate this to anything, right? Like, let's say it's an installation where you guys are you're tracking a bunch of people, right? And let's say you want to build the tracking system to grab all that data and handle everything, and then you got to hand that off to somebody makes a cool visual for that, right? So that's something that we do a lot at AVNC is have a bunch of sensors and then send sensor data into the network and then make cool visuals with it. Well, I don't really want to roll my own sensor code every time, so we'll do basically this exact thing where we've got sensor handlers and we'll hire like Vincent to make some sick shader, right? But he doesn't have to handle any sensor crap. You know what I'm saying? So you can extrapolate it to your workflows however you want. But the whole idea here is that you can just inherit modules, right? And then use them. So let's go now to the actual player extension here. So now that we've inherited the module, now we can run our own code for it, right? So let's say as the user, I want to do one of two things. I either want to overwrite the existing code that exists there, or I want to do a totally separate thing. So you can do that very easily by rolling your own code here. So typically what you'd want to do here is once you've inherited this code, you'd want to set up some sort of doc string here that says what's available for you, right? So here we have load media, which pass in media items and deck number and list. So basically what that would do is tells the user how this load media works, right? And how this load media works is, so now I'm going to start showing you a couple different things. How to come up with data structures to run your installation. And these are going to be super simple data structures, but it gives you an idea how to think about running code. And then next thing it's going to do is, actually that's it. Yeah, it's going to do that. So now, let's say we're here. All right, this wasn't it. So go to here. Go to JSON. There you go. So here we've got let's say we've got a show here. So this is a sample way to send data in. So this could be applied to really any concept, sensor handling, show triggering, but essentially it's a simple way to do things, right? And so now I'm going to show you how to like a modular way to bring code in from outside resources such as networking or from files, et cetera, and route that around your network. Because the first thing we need to understand is how to pull that data in, right? So in our scenario here, we've made a bunch of player attributes, and we've grabbed those attributes directly in the network, right? So I've got this movie file here, and what I'm doing is I'm just grabbing the information from the property storage here for each movie slot. So whenever I send information and update that slot inside the property, this player is going to this player reference here to that property is going to automatically update it. So I actually don't even have to do any code, right? I actually don't even have to like. Usually you'd say like, I got a new movie file, and let me go ahead and run op movie file player dot par dot file equals this, right? Well, you can do that, or you could just use these references like this. Now, this is probably going to be slightly slower to put these references on your operators in terms of cook time than just writing it one time. But for the sake of showing you how this works, I just wanted to do it this way. And also, it's not really going to slow your network down enough to really matter. So if you're really eking for those milliseconds, then maybe you don't want to do like referencing, format strings and parameters. But these days, if it's optimized, and it's faster than an export anyway. So, so for example, this one's optimized. This one probably won't be, right? Unoptimized. So it's going to run a little higher in cook time. But anyway, so I've got this little JSON file here, and basically what's going to happen here is actually, let me show you this first. So when this initializes, let's say I want to do some things like put different parameters, custom parameters, or parameters for, like, let's say movie deck A is a 4K, and it needs to have different read settings on the movie file versus like a 1080. Right, I want to pre-read n number of frames for this one, and I want to pre-read n number of frames for the other one. You could go in there and manually set them all, dial around with them, right? Or you could set it up through a config, which is, in my mind, a lot better, because if you need to change it later, you can have some system administrator change it, right? Versus you going in. So the whole point, a lot of this is like, what can you do so that like you don't have to go in there and do it later, right? Which you'll find a lot, like if you program a bunch of installations at once, then you got to go back 2 years later. Oh man, good luck. You know what I'm saying? So there's a lot of reasons for config files, and there's a lot of reasons for like creating a structure that works over and over and over again. So in this scenario, let's go to the config file again. So we're back to the old config file here. And so in our activation 1 here, right, got out our player key. And in here, boom, I got a bunch of parameters. I actually made them all the same in this scenario, but in the real world, you could have all sorts of different stuff. And you can, in the technique I'm going to show you here, is you can apply this to any operator and any parameter. And spam through your config file and update all your ops, right? Which is pretty nice. To be able to just like config stuff in one button or on initialization, right? So what we do here is create a key per deck. So in this case, we have 4 decks: deck 0, deck 1, 2, 3, and basically how we're going to do this is we're going to, per operator type, we're going to make a key. So in this scenario, we want to change some parameters on movie file ends. And another sense, we want to change the fit top, right? So we create the type here, and then as another dictionary, a whole dictionary of all the different parameters you want to change and their values. Does that make sense, guys? Cool. So yeah, what's up? At the type level, but this concept could easily be expanded upon, right? Absolutely. So all the things I show you here are easily expandable. Like I tried to make a project structure that was like real simple, and I wanted to make a project structure. That was my old buddy Landon. He worked at AB&C with me for years. He works at Obscura now. Good guy. Anyway, so I tried to make a project structure that is very simple, and as you can see here, like. If you open up all AB&C's projects, it's going to look similar to that, right? We have a communication base, we've got an output base, and then typically we have our key like modules, right? Maybe a player, maybe whatever it may be, right? Whatever it may be. And then we have admin overrides and we have tools. And that's about it. And then it sits inside of there. And the biggest advantage of this is that when you onboard somebody, not only can they extend it very easily, right, but also like they can understand it very quickly. And that's key. And as you can see here, I haven't talked much about syntax, but the syntax I use is like if I have a major component, it's capitalized. Whereas if I have a subcomponent that's not as important or it's not doing major stuff, it's lowercase. External operators are colored black. When I define my parameters here, or I define my attributes here, like if I'm referencing an operator, I always do lowercase underscores. If I'm referencing, if I'm creating a variable that needs to be exposed, it's uppercase camel case. If it doesn't need to be exposed, it's always undercase camel case. And so the whole concept there is that doesn't really matter how you code in terms of syntax, but have a method for your madness, right? Like, because the whole idea is that as you create whatever structure you're creating, you can encode data in your syntax, right? Which is like, it actually took me a while to get on board with that sort of concept. I used to like, when I first started programming Python, I would do like the pep style, like underscore everything. Like, you know, and that's technically like the way to do it that Python says, but I found that it's really easy if you're working with other people and everyone adheres to that code style, you can understand code a lot faster. Because some people, they'll do big old doc strings and they'll explain it all out for you. And that almost throws me off more than a simple readable comment with syntax like setups. And I think that's more purist. And also, when you're reading code, like, as you can see, I notate everything, but really simple. Like, you know, like it's like, you should be able to understand, like the whole concept of like programming in Python is to make it stupid easy. So you can like, don't outsmart yourself, right? Like I've outsmarted myself many times where I like make some crazy function or something that is overly complicated, and then I have to go back to it and I have no clue how it works. So the whole idea is like, I create things as simple as possible using the exact same syntaxing with simple comments and let the code speak for itself. And I think you'll find that is a really good way of programming. And for me, huge doc strings that break up the code make it harder for me to read. So I don't know if that's just how I work, but if you notate a lot, I won't get mad if you notate a lot. Are you saying the syntax highlighting? I don't have an actual there's like the pep style documentation on, which is like the standard way to do highlighting according to what like all the core Python developers do. And I didn't bring the I don't know if I can show like what we send subcontractors. But like I can briefly show you like in one of the extensions, for example, in the player mod here. when I initialize everything, right, my classes are always capitalized, always, right? And I guess they kind of have to. Actually, they don't have to be, but that's kind of the standard. And then any operator that I want to, any attribute that I want to have exposed to the network, Touch Designer did a nice little cute thing where they basically make it promoted, meaning like if you capitalize it, it's promoted, meaning that that attribute is accessible outside of the class, meaning you can access that inside the network, right? So like if I were to just set a variable here, it's called self.td, right? I could grab that variable inside Touch Designer by just going op.playermod.td, right? So that's basically like, here, I guess I can do that. Oops, I should probably assign a value to it, right? So I left all this, I didn't want to go too deep into like what the code is doing, but I left it all there for you to explore later. So, but anyway, if I go into like player mod now, so really anywhere I'm at here, but if I throw an eval down here, that's right. Sorry, this is a bad example because this is the player mod, right? So I don't actually want to grab the module because that's the module, right? I actually want to grab it because I'm inheriting it over here. I want to grab it to where I'm actually using it. Parent. Maybe I need to initialize everything. It's odd. Didn't save there, huh? There it goes. Had to resync it. Yeah, this sync to file is pretty solid. It should have been fixed. Maybe it's because I didn't. Oh, it's probably because it's the mod and not the extension. Yeah, what happened there is it didn't sync properly. Yeah, that's annoying. Anyway, there you go. So there it is, right? So now, if that was lowercase and I did that, it wouldn't get it, right? And so the whole idea here is like, I'm trying to teach like concepts and not necessarily like, here's how to do everything. But the concept of this is like data fragmentation, not fragmentation, modularity and encapsulation, really. Like, how do we think about encapsulating data that some people need and some people don't? And that's the core way of in my syntaxing is that, like, if somebody gives me like I've had many situations where somebody's programmed something and they've done the syntaxing, I can look at crap and be like, well, that's lowercase, or a lot of times you'll do in Python, you'll do these little underscores to indicate that that's like a hidden attribute and it's only accessible, on locally, and it's a really easy way to understand what's going on really quickly. Yeah, and then the other stuff I do is if I'm doing uppercase, camel case for properties that need to be accessed, right? Lowercase, other than that, and that's really that. I mean, that's really that. I mean, there's really not much more to it than that. That a good? Sorry if that's a bad answer. Cool. Yeah, I don't have it like documented anywhere officially. I have a syntax guide I send out to subs, but that's got a bunch of stuff in it I can't share. Yep. Anyway, so back to track here. So what we were talking about is this config loading, right? So we've loaded assets, we've loaded activations, and now we want to load specific parameters. So I've done that here, and then basically the code to do this, and I would recommend looking at this maybe on your own time if you don't get it, but it's pretty simple. But basically what it does is it pulls the self.node, right? What I did is I grabbed the node, which is the very top level that has all our data. Grab that data, set it to an attribute here, local attribute, and then I got the player key. So that returned right here in this variable, we've returned this whole thing. So now our network has this entire data set to use in our network. All right, and then basically next, we just spam through it. And the trick here is to make sure you're naming your ops correctly. Let's see if I can, not a lot of screen real estate here. Trick here is to name your ops a certain way. So, oh, right, actually, you can name a certain way. Actually, in this case, I used a player tag. So what I did was I went into here, and each op that I wanted to use, I set a tag to. Set the player tag. So I did this earlier. I showed you when I initialized components or whatever. This is a clever technique I found that I use all the time to just do like stuff to a bunch of operators easily. Just set tags to them, look them up, spam through it. So on the 2 movie files here and the 2 fits, I've set the player tag to that. And then, simply enough, for each key in the player config, so each key, each deck, this deck, this deck, this deck, and this deck, I grab the tags for each of those. So self.owner comp key. So each of these key represents a name, a key name here, right? So then basically what I'm doing is self.owner comp op deck underscore 0. So it does do the naming as well. So what's happened is that self.owner comp, which is our component here, then this operator. So now we're in this operator. And then for operator in tags. So for every operator that we have in those tags, we grab the operator type. And then for each parameter in those operator types, we grab the operator's parameter value. We grab the operator's parameter, the actual par, and then the par value, and we set the attribute. So basically what that does is it just goes through, finds every single op, and writes the values to those ops. So hopefully that makes sense. Feel free to look at that later. But it's a really helpful technique to think about. At the end of the day, touch designers or operators in Touch Designer are like dictionaries, right? They're just lists and dictionaries that contain values, and they're an object, right? So all the objects have attributes, and you can access those attributes very easily. So basically, when this thing initializes, because let's say, for example, me as the developer who gave this to somebody, I have no clue what settings maybe they didn't want to do this at all. But the idea is that the developer has full control to override or do different things in the player extension without me having to know. And then another basic thing of initializing timers. So great. So now that I've kind of showed you what happens there, I'm going to kind of show you how do we route data around to different. Let's say we have data that's coming in. How do we route that data around? So at this point, I'm going to make sure the logging is on, and you guys can check out like how logging works, right? What's up? Sorry. No, anytime. Yeah. Boom. No doubt, no doubt. So basically what happens here is that, let's go like this. I didn't hear the first part, sorry. Right, yeah, exactly. I mean, I'm not quite sure I'm following the library part of it, but. Nope, yeah, it's not a library or anything. All it is that, like, for example, so if we look here at the movie file. So this is a movie file in, right? It has these tune parameters on it. And what I do is I'm matching the parameter name with the key that's in the dictionary config, right? So this only works if you name your dictionary keys the same name as the parameter names of your object. So that's what I'm doing is I'm finding the operators that I want to write to, right? A, finding the operators I want to write to. B, finding the parameter names that match in the config file. Then I'm writing that value to that parameter. No. Yeah, precisely. So I specified this config file when I loaded up. So that was the, if we go back, yeah, exactly. So to quickly recap that, if we go to this config file, oh crap, sorry. Boom. Up. So we go to this config file. The core concept of this is this activations, right? So we have two activations here, and shortly we're going to get to handling more than one activation, launching from the same project, which will be the last part of the talk here. But this activation right here, as you can see, what happens is that this is a list. This activations right here, as you can see, it's a list. This is a list of dictionaries, meaning that when I inject an environment variable, I'm setting the environment variable to the index that I want to launch up, right? So let's say I want to launch up activation, this first activation, that's in index 0 of my activations. That's what this bat file is for. So that allows us to not have to really deal with TOE files, have one TOE file, and then check this out. So in this edit here, this node, that environment variable, so what happens is that it injects that, it starts it up, and then the first thing that runs in this entire project is this node code. Sorry, let's see. I don't know why I closed that out. So what happens here is, sorry if I skimmed that over too fast. What happens here is that this first line loads the config that I created. Because what this does is it says, basically create some properties and store them in persistent storage in Touch Designer so that it saves through initializations. Runs this store config and load config. So runs this load config first. And then what it does is it says, see this line right here? It just loads, it literally loads this file. JSON.load loads this file from disk and stores all the keys as a dictionary. So basically what I've done is I've just loaded this file. I've loaded this file right here into this variable right here, right? And in order to look it up properly, it uses this, where's it at here? Do I haven't looked this up? Here it is. Sorry. So here, this node, so node store.append, I create a property called node, and I look up in the config the activations key, right here. So I look back at my config. I load my config, I look at the activations key, right? So config, which is my config activations. Then I grab my environment variable. So this var node is the way in Touch Designer to access your environment variables. So you can actually see that here too. I have this var tt. Basically what that means is it's like, if we go to this diagram, that's what I was showing you before. It wasn't showing my environment one, I don't know why, but variables and macros. If I do var desktop, right? So what happened is that I injected that node environment variable, and it had a 0 in it. So that's what I used to look up the index. Make sense? Cool, great. So yeah, it's not automatically loading a config. We are doing that ourselves manually, And that's the whole kind of concept behind config-based startups, is that you define whatever you want, and then you load it up however you want, right? And then this really enables you to segment out the code, because I can have all these things different. Like when I work with somebody, I can have them just work in this output, right? And they're not going to touch anything other than the output, and they're going to just save that talks. And then when I go to save other stuff, it's not going to have a version conflict. Like we both worked on something. Whereas if we had a tow file, second you make a change, second I make a change, they're out of sync. There's no way to resolve that, right? And that's the whole point of GitHub, right? Is that you know, if I open up GitHub here, it tracks all my changes, right? So this is the GitHub repo here. As you can see here, like I've made this, if you look here, so I've made a bunch of edits to my actual Python files. I should probably set this to git ignore, but my bad. See all these changes that I've added in? You can actually see them, right? Oh, I added value here. I created a text file here. But check out these toxes. See the toxes? All you know is that a change was made. You don't know what change was made, right? And how that is really important is that when you use GitHub and you use like external files, you can just override, you know, you can choose which one you want to use and override and see exactly what's changed. Whereas if you just use a tow file or a tox, you have no idea. You can't see what's changed. You're running version conflicts and stuff. I didn't want this to be like a GitHub session, but the whole point of using the actual external files that aren't binary is to be able to track your changes. So when somebody sends me a big pull request for a bunch of stuff they've changed, I can review the entire amount of code that they did and see what happened and changed. Right on. So anyway, that's a technique. I kind of want to get to the outputting and the other. We got about, what is it, an hour left or so, to the outputting and the secondary instances and stuff. So hopefully that made sense. 1 second here. So anyway, that's a technique that you can use to like override functions and use your own and do things where you can, you know, load up custom things from the config. And hopefully the idea is that you can put anything in a config file, right? It doesn't matter what you put in there. You can do whatever you want. I'm just showing you some different ways that I've found to be powerful, but I mean, you can make these way more simple or more complex. Like some of our projects, I mean, we're looking at like 15 different unique activations. Some are multi-GPUs. Some are like multi-computers where we have a sync and sending it out. But the idea is that you can do this same concept that I'm showing you here at a simple level and expand upon it. Or if you're just getting started, you can make it even more simple and just put in some real basic stuff. I wanted to try to make it like intermediate so that it gives you an idea of the things that are possible. So yeah, and also like if you look here, for example, I even added stuff in here that I'm not really using. Like for example, like you could dynamically load pixel maps, right? Like, so we'll go to that now as like, you know, we have this, like, so we send in data, right? So let's say we have this output here, right? Let's say you had to change your pixel map on the fly, like, you know, you go to an event or whatever, and, you know, some guy gave you the wrong pixel map. You could put that, you could put that item in your config, and if something changes, you just change it on the config, boom, and then it loads it up automatically. So let's go through quickly before we go to the output here, the how to route data to it. So for example, so if I hit this demo button here, what's happening here is I'm just like randomly choosing like decks and random media. So you'll see it'll choose between 1 and 4 items, and it'll play them. So we'll eventually get to see them play different items here. But as you can see here, I've got the logging going, right? And if we go here and we go look at my code, I look at my code here in the player mod, I've got all these little print statements in here, right? So I've got like, you know, logger.error if something fails out, You know, and one thing here that you can note is this traceback. This traceback module, if you import traceback at the top and basically put this this code right here, what that'll do is it'll get your stack trace. So if anything errors out, it'll go through the entire stack trace of what code was executed and dump it out for you. So you can see where in the entire chain it broke, which is really powerful. And also if you have a warner or a logger on that, it'll dump that to a file for you, and then you can automatically see in a file or whatever, or you know, an alert, it'll show you where it's at. So anywho, let's go to the controller code now. So at AVNC, you know, we have like lots of different ways to send data around, but the primary method we use is have some outside controller send us data. And so here, what I've done is I've created a little I just put a little TCP down as the server, and this is the controller. And as you can see here, you can start seeing how this logging works, right? So what I've done here is on this controller extension. So this controller extension right here is the code, is this. It's the code for this controller. And what I've done here is I've created a little property. Where did I do it? Oh, sorry, wrong one. Was it? Oh, right, that was in my monitoring. Excuse me. In the monitoring here, if this thing ever turns off, what happens is it realizes it very quickly and tries to turn it back on again. But where I want to show you something else. There you go. So here, so as you can see, I've got this little monitoring set up. Every time I turn this on or off, you're going to see here in my controller code, I say, you know, what's connected, what isn't connected, and that logs it to file. So this is an idea of how to use the logging to determine whether or not if, you know, you've connected, if something's disconnected, stuff like that. So what I've done here is I've set up a sample little payload generator. So here, I made a couple different sample payloads. I was showing you this before, but if I go to like single deck and I send, what's going to happen is it's going to send one item to, it must have been that one already, so it's going to triple. There we go. So as you can see here, it just transitioned, right? So what I'm doing here is I'm loading up, this is simulating somebody sending me a JSON payload and me doing something based off of that. And so how that works is like this. So let's say I want to change, you know, 4 decks at once. I want to change all these at the same time. Well, I go to quad deck here. Here's the payload for that, right? Somebody says, what's it going to be? It's going to be a show. So, you know, in big installations, you'll have different commands that do different things. Let's say this is a show, right? And then we just want to put that data somewhere. And then here we say deck 0, 1, 2, 3, 4. And what happens when you hit this send on this, it should just change them all. There you go, real slowly, right? So it'll change them all, but what happened there actually was that inside my controller code here, so right here in this code, what happened was that this sent it, so that button said sends this to here. This is my receive, right? So if I do that again, sorry, huh? Oh, it's local. Yeah, this is like a real slow machine compared to you know, what I built this on or whatever. So obviously it's loading like 4 videos at once on this little piece of crap. So it's super, like it's the frame rate's getting rocked. But on any reasonable system that would have no problem. It's perfect 60, no problem. So when I hit my communication send here, what happens here is, is it the port's all messed up, huh? Sometimes these ports get messed up. There it goes. Yeah, sometimes you get port lockups like that. So I just changed the port and it worked. But what happens here is, check it out, I send. What's happening is that this TCP IP data is loading that JSON file and sending it to me. And so this is like super, super common, right? Like sending data over the network and then having to like, how do you get data and then do stuff with it? It's like somewhat of a complex topic. Well, it's not complex, but if you've never done before, it can be confusing, like how do you do stuff with data, right? And basically you just match key values in dictionaries and then set up logic to route it places, right? And so that's where this code gets really powerful. Is what actually happens here is that when this is called, when I receive something, I just call this onReceive function and pass in the message, right? So basically what happened there is that it's received the message, which was that JSON payload I just showed you, sent it here to this onReceive function, which again, it's promoted, so I can access that from an operator outside the class. And then what it does is it loads the message, and then I just dump it right here so you can see it. I do that so that it, like, you know, you got a nice, pretty spot to look at it. Another thing for visibility is to be able to see stuff. Dump it there, and then what happens here is it goes through, and this is some, I would recommend looking at this maybe on your own time if you don't understand it now, but the really powerful part here is this line here. So this is essentially boilerplate code that you can use for everything. And it's essentially what happens here is that you pass in the message, and then it just makes sure that it has, sometimes you get like blank packets in TCP/IP, so you just make sure it's not that. Anyway, so then you check to make sure it's a dictionary, because that's how our message format was set up. Then you check, you pull the command in. So what happens here is it says payload get command, right? What that means is it pulls and it says get the command key. So our command key is show, right? So now we have a command that equals show. Then we go here, it says if command is in self commands. What is self commands? Well, self commands is a list of commands that are going to be valid for the project, right? So this is where our projects start getting real complex. We'll have lots of different commands. And, you know, if this is getting back to the thing I showed you before, using lookups and calling functions from lookups. If you didn't have a method to store values and then call them, you would have to do like a bunch of if-else statements. If command equals this, if command equals this, if command equals this, and it's going to get real verbose and not efficient. So what you can do here is just define a list of commands, and in this case I have one command that we're going to be using, and it's called show, and it's going to always call self.route message, right? So what happens here is that if that comes in here, it's going to say, oh, we found it, and then it's going to say run self commands, which is this dictionary or this property. If it's in there, run the commands, and then pass in the command. So it's saying in this dictionary, find that key, and then run this payload. Run the function. See these curly brackets here? Curly brackets means like function. Run the function, and then pass in the payload. And this dot notation, or the asterisk notation means pass in the dictionary as a set of key vals. So basically what it's going to do is it's going to pass in as arguments. So it's going to pass in this entire dictionary as arguments into the function, right? So basically that's how you can send a huge payload to somebody, and then you just asterisk that, and it'll send in all those in as keyword arguments or arguments. You can do kwargs or regular args. And then basically what happens is that there's a bunch of error handling here. If anything fails out, logger.error, logger.info, you'll get your logging properly. And then it'll basically send it here. And then you can see this kwargs here, right? Because what I did was I said asterisk payload means it sends arguments in as keyword arguments, meaning like, you know, the keyword arguments in this case would be parameters, right? So it sends in that entire key in. And then I just grab and then at that point you can do whatever you want, right? So this is boilerplate code that allows you to work and route data around efficiently. So here we just grab the data, and then we grab the, this is another config-based thing. So go to config. Here, in each of these, I've got this mode. And that means, like, where do I want to send my data, right? You can do anything, but in this scenario, I have this mode key. And it allows me to know that I want to send this data to this player component, right? So mode, and then this little line here looks more confusing than it is. But basically, I'm just calling this run function for the player. So basically what this says is it says args.0, which means that this, right? So arg0 is this. And if you look up run, do you guys know about run delays? Run delays to touch ladder? Yeah, so for those of you who don't know, there you go. So this is how you can run things with delays, which is very often necessary when you're doing big installations, because you need to like something didn't load, so I need to delay this by 1 frame, right? So you can do this run, you can execute commands, execute functions, execute anything you want with any variable number of delay frames or whatever. So the syntax for it is what I'm showing you here is run, pass in the script you want to run as a string, and then pass in your arguments, and then pass in the number of frames you want to delay. So that's what this is, right? arg0 means basically like this is the you see these little strings right here? This is the command I'm running because it's a string, right? So basically it says run this string. This string is arg0, means that the first argument is this, op node dot format mode. So it means op node mode in this case is player, right? So op mode player. And then the second argument here is the actual function to call, and then I'm passing in the data. So basically all this function is doing is like allows you to have, like, I don't have to change this code at all. And I can have any number of installations or activations, and just like this code will work for all of them. I don't have to change it 1 bit. And so that's where I'm trying to go with like creating modular code that you can reuse. And in this situation, I don't have to change this code whatsoever. All I need to do is create a config item with where I want to route my data, right? And so in this situation, this situation is a little more simple because we're assuming we just have one component we're going to be sending data to. But you can see how you could expand upon it and send any number of it. And so what happens is that it sends this data to player, and it sends it and it calls run. So that's what you'll see here, dot run, right? So I'm passing in dot run. So basically it says op.player.run, pass in the data. So basically all that says is go to this module player and call the function inside of that. Let's see. Run. I'm calling that function. Does that make sense? Right? So basically I'm just calling that function, and going forward, any other activations that you have, you can just have that function, you can just have a run function that sets it up. So this is another situation where you can have code that like when we work with subcontractors, we'll just have this code in there, and they don't need to worry about it at all. We just say, hey, listen, there's a run command, a run function in there, and it's going to send you the data you need. And then you can do whatever you want with it, right? So therefore, you don't have to change your code ever. Sometimes the needs of the project may require you to update your infrastructure a bit or your framework, but in general, this concept can be scaled up as large or as small as you want with no problem. Does that make sense? And so that's how all of our installations are set up, is with this concept in mind, by creating a way in which we receive the data uniformly and sending that to somewhere in the same way. And then what we require is that, let's say I hand it off to you to make a module. All you need to do is have a run script in there or a run function in there. And then if you're going to send anywhere, all of our other modules have like run functions in them, right? So that if you ever have data, you just put that run function in there, boom, done. And then you can send data around in the same format over and over and over, and you know exactly where to look. And so that's kind of the concept of, yeah, that's the concept I wanted to show you of like how to send data around as a controller. Yeah, and then another thing I wanted to show you is this this environment. So this environment here is when you're developing, like obviously we have the config file here, and anybody can put in their own local path to assets. So when you're developing or whatever, but also like when you're developing installations, these installations can last 6 months of development time or whatever. You're not going to have the final IPs for the project until the hardware installed on site or whatever. So you need a way to be able to like switch IPs and switch network information without having to like manually change stuff. So what we do is we create this environments. You have any number of environments, and so in this case, we have IPs and passwords and whatever different monitoring services we have. And as you can see here, what I've done is I've created a production environment and a development environment. And when the project loads up, let's see, when I go to the node extension here, right, when the project loads up, again, it's loading up the config, storing all the values, and now I've got a property in here called environments. I've got a property in my network called environments that I can use anywhere in the network. And what I've done here is I've created a property on communications component. Right here. So what I've done here is I've created a property here called environment, and I've put a setter on it, right? So if I look here, I've got this is what I was showing you earlier, right? I've got this little par execute. And what this does is this is a way to call properties on your network and optionally run the setter if it exists, right? So what this is doing is it's saying, does par.owner, meaning does the parent have a par named? Yes, it does. It's called environment. And then if it exists, run the, set the value, because that's what properties do. When you set a property value, it will run the code in your setter, right? So it's a way to basically have functions without having to create functions, essentially. These are little setters, right? So what happens whenever I change that value, this realizes that value change, checks if the property is there, and the only thing you need to be aware of is that you need to make the property name the same name as your parameter, right? So my property name is called environment. So when that parameter executes, this is this catch-all I was telling you about. If any parameter changes or any parameter on that object changes, it'll check if there's a parameter, a property, or a function or an attribute that's on that extension, and it'll run it, right? And so what happens here is I change the environment, and it runs this code. All it does is it gets the value. So what happens is it runs the getter, gets the value, then it runs a setter, returns the value, and then it turns the controller on and off again, the connection. So basically what happens is it just reinitializes the extension, right? So then if you look here, see those IPs change? Right? And so what we would do is we would have anything that's hooked up to a network at all, sensors, whatever, is going to be driven by a config based off an environment config with development or production. And that's how you can just, so now I'm developing, great. I go to site, all I got to do is hit that button, and then everything works. Which sounds very novel, but if you don't have that set up, big pain in the ass, believe me, because you're going to end up having all sorts of different network problems. Anyway, yeah, so that's that. That's basically how we route data around. That's kind of how property par works. Any other questions? I'm going to move to the outputting and secondary instances now. Hopefully this is making sense. Right on. So I'm going to just show you a couple techniques that I've found very valuable in setting up outputs. And these are going to look real novel at this scale, but they're pretty powerful at high-end scales. So in this scenario, right, we have like I have one tow file, right? But you need to set up your windows for multiple different configurations. Well, how do you do that? Well, you can config it, right? So in our projects, we always have one output base, right? And that one output base is going to be the same output base for all the different installations or activations, right? For most scenarios, if it's small enough. If it's big enough and complex enough, we might break it out a little bit more. But for the most part, we'll set everything up in here. Like we'll set up all the different activations. And the thing is it's a switch network, so none of your data is cooking if you're not outputting it properly. So you can have a bunch of stuff in here, so long as you're not like processing stuff in there, you're totally fine. So what happens here is that in the config file, we've got this little window config here, right? So every single activation has a window dictionary, right? That loads up, and then what happens is that on our top level perform window, we're just grabbing all these values, right? So basically what we're doing here is looking at the node, pulling the window, pulling the value, and then setting it a default value if it doesn't exist, right? So basically, this window can be completely configured via a config file. So this is how you can set up, like, if this needs to go to a different monitor, right? Whatever. If this needs to be justified differently, if it needs to be a custom thing, like in like multi-GPU installations, like, this is how you can turn on, have one operator have draw on, another on. Like if your master doesn't need to draw, you can config that from your config. If you need to have vsync off, or if you need to have hardware frame lock on, whatever. You can do that by just launching up different instances of your activations with different windows. And then you'll see here as well, we should have like a output, actually just mode here. So we have this mode variable, and then so this code's a little clunky here, but the actual code we use is a little too verbose that I didn't want to deal with it. But if we look at this output extension, basically when the thing starts up, sets up the output, just checks which mode it is, and then does different crap depending on the mode. So in this case, it's just, if it's a player starts up, it's going to write these tops, pull them in. If it's the messenger, it's going to write here. What's up, it's going to put the messenger in here, right? So now that we've started up the project and we're routing it, right? This is the really powerful stuff here, is how do we set up our outputs? So in this scenario, right, we have, let's pretend this scenario is 4 off one PGS, or sorry, one computer, we want to output 4 different screens out of one output, right? So in that case, and let's say that we send it to an LED processor, it needs to have a pixel map, right? So what we can do is we can actually just create the UVs and map it. So a lot of times you'll see, like, if you're setting up a pixel map or whatever, you've got a bunch of overs, a bunch of compositing, moving your different items around, and that's highly ineffective because it's going to be a lot of cooks. Or you can use a shader, which would be about as effective as this method. And send all your outputs into a shader, move them around. This method is actually something pretty clever. I would highly recommend taking a look at it. This is essentially, you can just remap the UVs from what you're feeding in to what you want it to be, right? So in this scenario, this is our actual output, how we've lined it up in touch design. We got our 4 outputs. Let's pretend this is a 4K or whatever. We got them here. We feed this into a remap. So here's the UVs for this. And then we can feed it into this remap and feed it how we want it to go. Right, so that's where you see this. That's what the LED processor would use, right? So that's like basically set, because it would be kind of cumbersome and annoying to set that up with like tops or a shader. But if we did, and it's really easy to just like route them all together with layout. And then this little component here is pretty clever. So basically, you can set up your UV coordinates with SOPs and pass in point attributes, your UV point attributes. So in this scenario, if we look at the custom parameter here, we've got our raster resolution, which is what our final output's going to be, our output to our LED processor, which, usually they're just 1920 by 1080 rasters. Then we feed it our canvas resolution, which in this scenario is this resolution, right? And we're going to just swap UVs, right? So to do that, you create your geometry essentially in SOPs. Now they need to have the exact same number of points. So if you look at num points here, 20. Num points there, 20. If you don't have the same number of points, you're going to get an error. So let's look at this first. So what we'll do is we'll look at our canvas. So let's create our canvas. What is our canvas? Well, our canvas is very simply a 960 by 540, this guy. And it's a 480 by 270, these guys, right? Then, very simply, you just put those into real space, right? So basically with this, you can translate them to where they need to go. This, at the end of the day, you just need to have this match that. Make sense? See how they're the same? Okay. And then you want to make sure you set up like you want to make sure that like you have your final raster here too, right? So we have our bounds that it sits in. So we have the bounds that it sits in. Pass it in. There we go. We've got that. And then basically you do the same thing over here, right? But you need to have the same number of points. So basically you create the same number of guys, move them around, set up your bounds. Then basically you just got to create UV coordinates so they didn't exist before. Create the UVs. Add the texture points here, the UV coordinates. Then here, basically you can delete. At this point, you needed to create your UVs with the bounds in place. Then you can just delete the bounds. You don't actually want those in there. So then your end result is this, right? You've got one set of chords for your output and one for your actual canvas. Then you just render them, right? And then basically what we're doing here is this Phong material here. You can output the, where are we at? Under advanced here, this is the material for both these geos. In the first buffer, we're going to output the color map. The second buffer, we can output the texture coordinates, right? And the texture coordinates is really what we need. So that's what this render, both these render, grab the UV coordinates of our actual output, and then put our output right into it. So this is like, pretend this is our output. You don't technically need this stuff. This is just to verify your mapping. Then pass your, your canvas resolution into the remap here. There you go. And so then what you do is you can just save out the EXR image that stores the UVs, and then use a remap here. So seems novel for this scenario, but like as an example, one project we use this on, we have we have a 26K wide LED screen, right? And that gets comped up into two 4K outputs. So you have a 26K screen, and you don't want your designers to be dealing with like the comped up pixel map. No designer is going to want to design with the pixel map or send you assets with the pixel map. No way. They're going to want to just send you what it looks like in real life. So what this allows you to do is have designers just send you whatever the actual canvas resolution is, and then you can remap however you want. So 26K into two 4K outputs on one, and then the other one, similar story, like this one activation, 4 or 5 different huge screens. basically what you can do is just create these bad boys with however many of these you need. This little check remap here will swap them out. So it'll swap it out, and if it's all black, I got a difference top in here. And basically what happens is that when you do this, this is how you verify your UV coordinates are perfectly correct. What happens is that it'll switch it out here, right? And so as long as the difference of this and you put this texture onto this geo here that has the canvas coordinates, and then you pass it in, and then if that's not all black, they're not matching, right? So that's just a quick way to check it. You want it all black, because if it's differencing and it's exactly the same, it's all black. And then, yeah, you don't need to have these cook at all. And then at the end of the day, your entire pixel, because at the end of the day, when you're dealing with a 26K canvas or whatever, comping up a bunch of pixel maps going to be, it's going to blow your GPU big time. So with this scenario here, at the end of the day, the only thing that is cooking for your entire pixel map, your entire raster comping, is this remap top. Nothing. Also, you'll probably need a multiply in here just to make sure that everything's getting comped properly. This remap top kind of doesn't like to function properly, but so yeah, at the end of the day, you got a couple ops that are cooking, and you're well on your way. So hopefully that makes sense. Now I guess the last thing I want to talk about is the way in which we can launch up different activations, right? So I've been showing you that player comp this whole time. So let's boot up. I've had 2 instances running this whole time. Great. So let's go ahead and boot up the other one. So here's our other instance. Basically, node is set to 1, right? So instead of node being set to 0, it's set to 1. So basically, again, that just grabs the activation of the other in the config here. Just to reiterate, right? It just goes in here, grabs the second key in the activation here, right? And then it's going to just use these toxes instead. Right? Again, the same story. And then let's launch it up. So booting up. There you go. So here's the secondary instance, right? And as you can see here, I don't have any admin control, and I've got a messenger component here. Makes sense, right? Pretty simple stuff. And anyway, so and then also you'll see here in the output, what happened here was that instead of writing these, it wrote this, and I'm using the environment variable here to use a different remap. Right? And so in this instance, I'm remapping this into this. Make sense? And yeah, so then another technique I wanted to show you was dealing with text in large scale installs. Probably like one of the more difficult things to deal with when you're dealing with like big data sets is loading the data sets in real time without just stomping your system. So you need to like really think about how you're managing your stuff. Like, you want to use as little system resources as possible. And so one technique that I use a lot doesn't necessarily you can't necessarily like load like a million text items at once because you're still loading the text items, but keeping your overhead low is to route all your text into one pass and then move it around with the shader. I didn't want to make this a GLSL workshop or anything, but basically what this does, it's a single shader, right, that passes in all the text that we have for the installation. So in this scenario, right, like let's pretend we got 2 different sets of data that we need to like have in our system, right? And in a real life scenario, like you've got a bunch of different screens. The designer wants to load up text with this screen with this text, and this screen with this text, and this screen with this text. And it doesn't need to animate or anything. It just needs to be placed in the right spot and just load up every time, right? So you don't need to be loading real time. You just need to load it up once, or you just need to load it like on a show change. So you don't need to have like a bunch of different geos and have your network get all crazy. One method you can use is to use a single geo item and just stuff all your text in there, right? So what this component does is basically just creates a couple bases, each representing their message. Then inside the message, you can have a bunch of different sections. So let's say I wanted to have like this section, excuse me, this section, for example, is just this, this Touch Designer Summit stuff. So, sorry, this, one is that, one is this, right? The two messages. And then in here, you can join as many as you want. And then the key thing here is that inside of here, you can move it around however you want, right? So you can set up all, like I've set up a whole component around this that I use often that, you know, you can, all custom parameters linked up, set up stuff very easily. But the end of the day, the concept is just feed in a shader array of your values. So this is my U and V coordinates, right? This is my color. So you can see how like adding some custom parameters on this would be really powerful. And then your text items right here, right? And the great thing about this is that you can set different text fonts, all that good stuff. Then the core of this whole thing is that you pass in your own custom attribute per text item you want. So here what we do is we have a text sub. You know, we align it how we want with our pivot. Then for this text item, I make a custom attribute called VI, vertex index, whatever. Me.digits. So this one has 0, 1, 2, right? So in a shader, I can access these by accessing this custom attribute individually, right? And so let's say that's this is my first message, this is my other message. Same concept here, right? And then in here, I've got the same concept, different text, different, you know, accessing them the same way. Then over here, if I want to switch shows, I've just got some switches here that just feeds in this block of text versus this block of text based off my show. So you can get the idea of like, let's say you had different shows, you could set up per show all your text for that show, all your show for that show, all your text for that show, and then just swap between them. And then you've got one geo that's running your entire world. So you've just reduced your overhead by quite a few draws right there. When you're dealing with text at 4K resolutions, that sort of stuff matters quite a bit. And then, yeah, I guess quick, if you can look at this later, but the code is pretty simple. Basically, we pass in a couple sampler buffers here. So look at this GLS on top, or excuse me, material. Pass in a vec2 array, our UV coordinates, and we pass in our RGB vec4 array, RGBA, as texture buffers, right? Then within the code itself, pull those in, and then we grab the custom attribute we pulled in, and then these lines are really what's doing it all. What it does is textile fetch, which just pulls it into your buffer, grabs the array for the UVs, and UVs per the group. So like, you know, the first text message was vertex index group 0, 1, 2. Assigns it to the red channel, U to the V, and then we just put the out color here. Again, we just do the same thing, but for the RGB array. And then we just move it, right? So this vec3 position, we just move the positions of the text and add and subtract the UV coordinates. Then we just pass that to our pixel shader, which is a standard pixel shader for outputting. And that way you've got, you know, one system that, you know, that doesn't even, it's nothing. So yeah, it's pretty scalable. Yeah, that's about it, guys. Guess I'll let you go if you have any other questions. Yeah. All good? Yeah, that's pretty much everything I wanted to cover. Hopefully it made sense. It's a pretty large topic, and it's hard to break down into like a modular way to see it at once. So hopefully that made sense. Yeah.